Welcome back. Now we will look in how to do statistical analysis of popularity. Okay, so I'm back at RStudio and we are in the file timeline.r. And in line 41 we do a box plot of the citations to the papers that have been published in journal. We can see the result in here. However, we can see that this result is not really so informative. We can see the number of citations is on the y-axis. So we have a lot of papers that have been cited only very few times, and then we have few papers, these are actually outliers in the figure, that have been cited several thousand times. And for data like this, the box plot is not really so informative. So in line 43, we get the summary of how the data looks. So we can see that the median value of citations that the paper has in our dataset is 18. So this means that 50% of the paper have 18 or more citations, and 50% of the papers have 18 or less citations. The lowest value is 0 and the highest value is 2764. We can see that the mean, which is the average, is considerably higher than the median. And this is because of this skewed distribution, where we have some articles that have very high citation counts, so they make the mean higher, but they do not affect the median. And for your data, you would do this analysis also for Stack Overflow in terms of upvotes, and for Twitter data in terms of retweets. Okay, let's try to have a more intuitive example of what this box plot means. So we take existing data from R, which comes from the cars, and this actually has fuel consumptions of cars, and it can be observed with different box plot based on the number of cylinders the car has. So we can see that the liters per 100 kilometers, the median value for 4-cylinder car is about 8. For 6-cylinder car, it's about 12. And for 8-cylinder car, it's about 16. And this thick black arrow is the median value, and this box is 50% of the data. So half of the observations are in here. The same information as in box plot can be taken out as violin plot, line 55 and 57. And this shows the shape of the data better. So the width, we can see that there is a lot of articles with 0 citations, 1 citation, and so on. And then we can see that the number of articles with high number of citations goes down rapidly. So the width in the figure says how many items there are with a particular number. So there's a lot with zeros, probably with ones, with twos, and so on. And then at 500, it's considerably less. Okay. So now we will do an investigation whether older articles are more cited than new articles. To do this, we execute line 59 that removes all the articles that have no date information. Then we take the median value of the articles. So then we get a split to 2 groups from the middle. We can investigate the median value, and it is 1st of January 1993. And we use this as a splitting value to the older and newer articles. And we can see that, at least based on the figure, there is not so strong evidence However, this figure still has the same problem that there is many articles with very few citations. We can also do the violin plot. That seems to indicate, kind of hard to see, this would actually suggest that newer articles have more citations. But again, it's a bit hard to see. So perhaps it's best to investigate the mean number of citations for old and new articles. And we can see, so we can see that indeed the newer articles have more citations. So the mean value of the newer articles where the date is greater than the median is 59, and for the older articles it's 44. We can also take the median value for the new and the old, and we can see that for new articles the median is 23 citations, and for the older ones it is 15. So we can see that the newer articles are more popular in terms of citations. Okay, so we can continue this analysis by looking at other factors. So recently, June 2018, it was claimed that for articles, the title length matters whether they get more or less citations. So one of the highlights of this paper published in Journal of Economic Behavior and Organization is that articles with shorter titles tend to receive more citations. So we have the data to check whether this is true for my dataset. So let's have a look. Okay, so we are back at our studio, and to figure out the length of the article, we simply use nchar function and we apply it to all the titles, and we split from the middle. And we can see that the median length is 63 characters. We could also consider words, but in this case we just consider characters. And now we can do a box plot by using this title length as a splitting variable and see whether longer or shorter titles receive more citations. So let's have a look. Okay, there seems to be some evidence that this is again true. We can see from the figure that shorter papers seem to have more citations, and what is notable is that all the articles with more than with 1500 or more citations have a part of the shorter titles. We can test this further by statistical test. And we can see that, however, we can see that this is not statistically significant. I mean, typically the threshold for statistical significance is set to 0.05, and this is 0.066. And again, to bring out if we take out the summary, we actually get more information. We can see that if the title length is greater than the median, then the maximum number of citations is 1200, minimum 0, and for the shorter ones the maximum number is 2700 and minimum 0. However, we can see the difference in median number of citations based on the title length is not very significant. So for the longer titles we have 17 citations, and for the shorter citations, for the shorter papers we only have 18. So there seems to be some evidence to the claim made in the paper, but I would not consider this as very strong evidence supporting the idea that shorter titles lead to more citations. There might be a small effect, but it seems to be quite small, at least in this data set. We would need to collect more data from more journals to make this analysis more robust. To have more accurate analysis, we can do a four-way split. So we do not split in the middle, or we split in the middle, but we also split at 25% and at 75%. This way we get four groups: for the ones that are shortest, then the ones that are short, ones that are long, and then the ones that are longest. And we do this on lines 102 and 109. And we can see that the shorter have advantage, or the shortest one have advantage on the most cited papers, but looking at what happens beyond is a bit difficult from the figure again. So we will investigate the quantiles, that is the 4 groups that we just had. We can see that the median is for the shortest one 18 for short, it's 18 for long, it's 18, and for the longest one it's 17. So again, the evidence is not very strong. So okay, a final thing we could do in this investigation is to have a better figure. So we have done so far the plotting on a normal scale, meaning that, you know, we get from 0 to 2500, and we can see that lots of the data is closer to 0. But we can do a log scale, which is done in line 116, and we get a different type of figure. As we can see, the papers with 0 citations marked with 1. As with log scale, we need to add +1 since log for 0 is undefined. So whenever you see a number here, it's actually increased by 1. So we can see that the median value, 18, is roughly there. We can see that for the shortest group, the box plot actually covers papers with only 5 citations and goes to 50 something. And then for longer ones, this is actually a bit higher. So overall, there does not seem to be evidence that the title length would influence the citations in IEEE transactions in software engineering.